This is the brief on MRI K-space, imaging physics and optimization. Okay, so K-space. It's basically the raw data we grab in magnetic resonance imaging. Think of it kind of like this abstract map we need to chart out. And figuring out the best way to do that is how we get faster, much clearer medical scans. All right, first up, the big idea. K-space is where the scanner gathers all this raw frequency data. Then, we use something called a Fourier transform. That's the math magic that turns frequency info into the final picture you actually see. Now, K-space isn't about where things are physically. Nope. It maps spatial frequency. So, the center, that gives you the image's overall contrast. The edges, that's where you get the really fine details, the sharpness. Second, how do we navigate this K-space map? Well, it's all about physics. We use magnetic field gradients, turning them on and off over time. See, applying a gradient nudges the local magnetic field, making protons spin at slightly different speeds. The scanner measures these speed changes, and that tells it exactly where it is in K-space. It's like a super carefully timed dance to collect all that data. And finally, this is where the speed boost comes in. Researchers are now using AI to seriously speed up MRI by finding smarter ways to chart K-space. They're using this cool technique, neural ordinary differential equations, neural ODEs, to dynamically learn the absolute best path through K-space. And what's great is this AI takes real MRI hardware limits into account, like how strong the gradients can be. Tests are showing this approach gives way better images compared to the old fixed ways of scanning. So yeah, this mix of deep physics and clever AI, it's really changing the game for how quickly and clearly we can see inside the body.